Okay, so it looks like some of you have caught on to the first one, so I'll just try to catch up to you. I would have rewritten this. There's the exponent of 2 there, and the cube root. So that'll be x squared minus 1 to the 2/3 if I was to write this as a single exponent. Then I could use chain rule here. That'll be 2/3 x squared minus 1 to the negative 1/3. The derivative of the inside is 2x. Okay. So in the next example, again, it'll be helpful to rewrite this before we try the chain rule. So if I was to rewrite this, I could bring that up from the bottom of the fraction, and now it's easy to do using the power rule and chain rule. So moving this to the front, it will become positive 14. Subtract 1 from it, and I get an exponent of negative 3, while the derivative of the inside is 2. Okay, any questions about chain rule in those 2 examples? If you're able to do both, can I just see? Because genius, really. It's usually this is one of the topics that students struggle the most with. So, okay. So all we're going to try now is, these ones are some good combination topics. So what I'd like you to try is these 3 examples. They use product rule, chain rule, quotient rule. They use a combination of things in there. So we're going to try these ones together just to make sure that you're on the right page. So why don't you work with a neighbor possibly to check your answer afterwards. And I'll review them on the board. Okay, so I'll do the first one with you. And I'm not sure what you're going to think of this, but
Whoa. What the? Where'd you get the 4 from?
this is a legit move. It's just that I'm being lazy here.
You're not being lazy?
I am being lazy because now I only have to do chain rule.
What?
So you could do it the way you wanted to do it, right? But you have all these tools at your disposal. If you wanted to pull it into the square root, you could do that and avoid the product rule altogether. It's not, both derivatives are going to be the same. If you do the product rule properly, they would be the same. We'll end up with the same answers, but you may decide that this saves more time than doing all the product rule stuff. But anyways, so in this example, using the way I had it, I'm going to have 1/2 x to the 4 minus x to the 6 to the negative 1/2, and that will be times 4x cubed minus 6x to the 5. Okay, so again, if we were to take our answers and plug them into a graphing calculator, we could verify by the picture that though they may look different algebraically, they are in fact the same derivative.
That's so smart.
Now, I'm just going to tell you, I don't think there are any really great tricks coming up in the other ones. One thing we could do, I mean, like let's just ask ourselves this now. What do you prefer, product or quotient rule? Product, yeah, usually product rule is the preference. So one thing I could do is, if I'd like to work with product rule, I could work with this as x squared plus 4 to the negative 1/3. That would be fine. And now I have a product instead of a quotient rule to work on. So this way I don't have to do quotient rule. In the next one, it's not going to be so easy to get away from the quotient rule. Okay, but in this one I would have, that's probably the move that I would have made. And again, whatever strategy you used, as long as you're on the right track with your calculus, we'll end up with the same answers after we simplify them. So for this one, the product rule is the one that affects both. Okay, the product rule is the bigger one that I'm going to have to take. That's the one I'm going to use first. It affects both pieces here. The chain rule is only being done on one of the pieces. So it's going to be a product rule, and inside of that product rule there's going to be a chain rule. Okay, so the first piece is going to be x squared plus 4 to the negative 1/3 plus x, and this derivative will be negative 1/3 x squared plus 4. And when I subtract 1, now I'm at negative 4/3, and the derivative of the inside is 2x. Okay, so it's not simplified. I mean, I'm not pretending this is a pretty answer, but this is onto the right track. that will get us the same derivative after we simplify. And I'm not going to take your class time to do that, but you know, this is a start. Okay. If I was to keep going, I'd be making common denominators and other things like that. But this is the piece here that used the chain rule. Okay. So here's my chain rule between those pieces. Okay. So the last one, as I said, I don't think there's any way around it. We're going to have to use quotient rule for the last one. So I'm going to give you just another minute in case you haven't gotten that far yet, and we'll reconvene. You can do this one together. Okay, so I'm running out of room here. I'm going to go to another slide. So let's try this one. If you haven't gotten there yet, then you can go along with me. So f of x is going to be 3x minus 1 over x squared plus 3. Is that correct? Have I written it down right? Yeah. Okay, so to take the derivative here, the chain rule is the outside one that's affecting everybody. I'm going to have to take the chain rule first. So that'll be 2 times 3x minus 1 over x squared plus 3. And it'll be times the derivative of 3x minus 1 over x squared plus 3. So here's where the chain rule comes in. In order to calculate this, I would have to do chain rule. See, it's possible for me to start, step number 1, I didn't need to know about chain rule. I could just start with quotient rule and see what fell out. Sorry, start with chain rule and see what fell out of it. So it's the derivative of the outside piece, which is here, times the derivative of the inside. So now I'll do this quotient rule. And this is going to be, let's see here. So the derivative of the top times the bottom, subtract the derivative of the bottom times the top, and it's the bottom all squared. So I'll finish this one off. I'll make it look a little prettier than that. Okay. So the piece I have here, I'm just going to try to collect up some like terms. So this will be x squared plus 3. And over here I'm going to have 3x squared plus 9. Take away 6x squared plus 2x. And if I collect those like terms, there's one other thing I can see here. On the bottom, I have x squared plus 3 and x squared plus 3 squared. So I can put those together as x squared plus 3 cubed. Okay, so for the bottom, let's see here. There's 3 pieces, 2 here and 1 over here. So I get cubed if I put them together. And 3x minus 1, can't really cut that down anymore. On this side, however, I'm going to be left with negative 3x squared and plus 2x plus 9. Now I don't believe that will factor, so I'm just going to leave it as it is there. I don't think I could simplify any more out of that.
That's it?
Question?
That's it?
Well, I don't see any way to go further. Sometimes your textbook does these crazy out of left field, like sometimes I have no idea where they got their algebra until I look in the back of the book. So again, my suggestion is if you feel confident about your answer and it's not the same as what the textbook has, verify it with your graphing calculator that you are correct and that it's just algebraically they look different. Okay.